and simulation in solar desalination systems. www.redsliberary.com.
Hi everybody, first Muhammad Shar with you. Let's talk today about how can we extract our analysis or data from Simulink model, especially Parabolic Trough Collector example. We have design and performance models. Suppose I'm going for a design model. Okay, this is our model. Let's go and save as let's make it trial in order to make our the changes and do what we'd like to do. Okay, anyway, first of all, a brief explanation about this. We have to assign some inputs. This model is for design aspects for Parabolic Trough Solar Collector. We can choose between three different working fluids. We have water, terminal, molten salt. Suppose I'm going for molten salt. Okay, therefore inlet temperature not below 150 inlet fluid temperature. Let's go for 100 and suppose it's 180 degrees Celsius. Okay, and we have outlet fluid temperature. Suppose I'm going for 450 degrees Celsius. Okay, and the solar radiation I'm going for 200 ambient temperature. Okay, these parameters are changeable. You can change these parameters as we are going to see now, and we can control mass flow rate. Suppose I'm going for 1.5 kilogram per second. This is hydro mass flow rate. Hydro mass flow rate is responsible for it's a parameter that can divide the solar field in two loops. So suppose it's up to your design. I'm going for 0.5 kilogram per second per each loop. Okay, per each loop. This collector leads. Suppose I'm going for 100 meters as a segment per segment. This collector width. You can control these parameters. It's up to your design and so on. Molten salt. Okay, let's hit apply, and we are going to control temperature and solar radiation effect on the Parabolic Trough design. Therefore, we have to go here. This is water, terminal, molten salt. Let's go for molten salt. First of all, if we are going to collect our data from data inspector through the Simulink, we have to assign output streams first. Therefore, let's go for B collector out. This is pressure, so I have to double clicking on this stream and write if outlet Parabolic Trough Collector pressure in bar. Okay, and I have to do this signal stream. Okay, or you can select all of these streams. Okay, and go here and select stream selected signal to data inspector and click. It's okay. You have to be sure that this visualized signal is appear here. Okay, let's go for the rest exergy analysis. Okay, and go here and stream. You can choose many options. Okay, and we need to discover the effect of mass flow rate. Let's go here and drawbacks, some drawbacks here. Okay, we need to inspect a feed flow rate. total mass flow rate, inlet fluid temperature, outlet fluid temperature, and solar radiation. Okay, but you have to write the name of this. Let's write solar radiation, watt per meter square. Okay, and go here for M collector, double clicking, mass flow rate through the collector, kilogram per second, and this hydraulic feed. Let's go for it's also kilogram per second. Okay, and sure, this is our edit, this block editor. You can reform here, or you can change, you can add some inputs. This is your inputs. You can add here inputs, and this is function name, and this is your outputs. Okay, let's go for inlet fluid temperature signal. I'm sorry, double clicking, T collector N, degrees Celsius, and the same for this one, double clicking, T collector outlet, degrees Celsius, and solar radiation is fine. Okay, I need to discover solar field area. This is collector total length, in meter. Okay, this is Reynolds number, if you would like to discover. Okay, loop length per meter. Okay, number of loops. Okay, number of loops. Copy and paste here. Control double clicking on the stream, and it's easy. Number of solar collectors. Let's see this one. Okay, pressure losses, no need for this. Efficiency of solar collector, let's go for this one. Okay, you have to prepare prepare your model for this before going to for inspection. This exergy analysis, no need for this. Okay, another thing you can do for data analyzing or extraction, you have to go here. First of all, click on just one click on your own editor. Okay, and go for this one. Yes, for molten salt, just click here, this block, and this is editor block, and you can here choose any parameter and go for description and save final value to base workspace. Okay, this is diameter, length. Okay, length of the collector, exergy N, exergy efficiency of the. Okay, you can click here, check this button. Okay, in order to save your data outside at Matlab here in your workspace, so you can easily deal with and do whatever. Okay, we prepared our model for data extractor. Let's turn this back. Okay, we intended to control some results, so we have to double clicking on the first block, the mother block, and return it to this. This is our destination, in order to watch the changes and so on. Let's go for here. I will demonstrate three types of data extractor. This is the first one. Okay, set your time limit to infinity. We are going to set our time to infinity and hit run. Let's hit run and see. Okay, let's begin. I'm going to change solar radiation and what's the effect on the field area and total length. Therefore, increasing solar radiation, it's a massive gain from the solar energy. Therefore, this reducing the solar field area is completely expected. Suppose I'm going for increasing little bit L temperature. Increasing L temperature, it would decrease also the solar field area because it increases efficiency of the solar field. The outlet temperature of the fluid, if you increase it means that you requested more energy from the solar field. Therefore, it would increase your collector area up to, suppose I'm going for up to 600. Okay. Let's go increase for total mass flow rate. Total mass flow rate sure would increase massively the field area because it's about the total thermal load. Okay, increasing. Okay, these three parameters are quite interesting. Okay, let's hit stop and see. Okay, after hitting stop, you have to click on this button, signal inspector, and see your result, and you can draw some figures and so on. Okay, these are our data. This is evaporation pressure. Okay, I think evaporation pressure is depending on I'm sorry, you have to. Okay, evaporation, I think it's the mini code. No, it changed it, I think. Let's go for solar field area. Yes, I'm sorry, this one. We are from here. Outlet pressure. Okay, this is outlet pressure depending on the variation of your inlet and outlet temperatures. Okay, the special outlet temperature, and we have here the solar field area. Okay, some kind of decreasing and then increasing massively because of changing the temperature and mass flow rate. Collector length, it will show the same behavior. Reynolds number based on mass flow rate. Loop length. Okay, this is your loop length. Changing collector efficiency depending on temperature variation and so on. Number of loops. Okay, this is your number of loops. Inlet and outlet temperature, and these are inputs. Okay, you have many choices. First, you can send this to the figure, as you can see here, clicking send to a figure, and you will realize that Matlab will send this automatically to a figure properties, so you can handle and you can use. Okay, we are still waiting for this. Okay, it sent to a figure. You can click on properties. You can click here. I'm sorry. There is some kind of delay. Okay, it's opened in as a figure, so you can deal with. I'm sorry, we can. I have to do it again. Okay. Okay, it's okay. This is your data properties, so you can shift and left click on mouse. You can remove these figures, and you can deal with this with your data. It's fully editable. You can change, move, add what you would like. Okay. Okay, another thing is you can export these. You can click here and export. You can choose many figures in order to export. Okay, and you can import. Okay, suppose I'm going for this one. You can export here. Click on export. You can write the variable name of the variables. Export data in a mat file if you would like. So you can to base workspace or a mat file. It's up to you. Suppose I'm going for this one, and I will rename it as a pressure P. Okay, or for workspace, include data to base. Let's go for workspace. Go for BB, for example. Let's go for exporting. Okay, let's go for our workspace, and yes, this is our data. You can click here and you will see your data with time. Use time. You can every second, as you can see here, visualize your data. Okay, you can deal with, you can copy, you can draw a figure, what you would like. Okay, let's remove this one. Okay, this is your data because we exported this to workspace as we showed earlier. Okay, this type of data exportation, it's quite interesting. I do prefer this one, and you can make another run and compare runs here. Okay, suppose I'm going for another run. Let's go for another run. First of all, I have to double clicking here and go for molten salt. Okay, let's hit run and make some changes. Okay, suppose I'm going for declination of solar radiation. I have to wait a little bit. Okay, I'm reducing solar radiation. Okay, and reducing inlet feed temperature down to 150, and reducing the outlet feed temperature, reducing the mass flow rates down to minimum levels. Okay, that's it. Stop, and let's go and see our results. Okay, we can compare runs here. Okay, this is the old runs. As you can see here, we will refigure it out again. Okay, let's go for our run. Okay, for this one, let's go for this is the third run, second run. Outlet, yes, from here. This is outlet pressure. Okay, it's comparing. This is the second one. This is the second run. Okay, this is the old one. The solar field area. Okay, changing because I'm decreasing. This was an increase, and this it was a decrease. Collector length. So you can compare your runs, your number new versus the old one. Loop length. Okay, according to your time limitations or time run. Okay, enough for this one. Let's go for another one, another type of data explanation. Let's go for here and dashboard, especially for if you are going to use Matlab 14 plus. You can use this dashboard scope. Let's go here. Okay, double clicking. I can add another one here. Okay, I'm sorry, it will slow down a little bit our computer, but it's quite interesting. Double clicking here, and we can choose, for example, enthalpy. I'm sorry. Okay, I'm not sure that dashboard scope will continue running. Let's go for this one. Okay, double clicking. Okay, and double clicking, and we can choose our signal. Suppose it's area collector. Let's go for, and you can minimum and maximum. Okay, minimum 0, maximum suppose it's 10,000. Okay, and hit apply, and we can add another. Let's go for this one. You can little bit emphasizing such in order to watch the effect. Double clicking, hit back again. Let's hit run and see. Okay, suppose I'm going for decreasing solar radiation, decreasing solar radiation. Okay, decreasing the inlet temperature. Maybe not fit for the range. Yes, 30,000. I'm going to increase solar radiation in order to get myself in the range of 10,000. Still not in the range. Okay, we are in the range now. Okay. That's quite interesting. Decreasing total feed flow rate, it will decrease the area, your area. Increasing it will increase your area. Increasing, decreasing mass flow rate, as you can see. Increasing or decreasing, controlling up and down. As you can see here, that's controlling solar radiation down to 500. So you can easily notice what is going on with your parameters. This is for solar field area. This is another type, as you can see here, up to 500. I'm sorry, 500. Okay. This is our 250 inlet feed temperature. Let's go for down to 500 outlet. Okay, and hit stop. Okay, and this is your final value. So you can realize the fluctuation of solar field area based on the control of your inputs. I'm trying to do this with signal scope. I'm going for suppose I'm going for this one. I don't know why it's let's try for this. Okay, I will see this later. I'm saying it's okay. Anyway, so this is another type. I did dashboard before with Parabolic collector. I will check this later, but you can use this type of data extraction in order to realize. Let's go for and set this for 40,000 meter. You can add many parameters here with different colors. Okay, but you have to emphasize this. Okay, because it's anyway. I will remove this. Okay, but never mind. Okay, we can format font style. Choose your font style. Times New Roman 8. Okay, no, 8 is not quite good. Let's go for 10. Okay. Okay, you can add many of these and see what's going on. Okay, this is another method. Okay, I will remove this in order to go for single point run. Single point run is a little bit different. You have to assign your inputs as a 1 point 500, 200, outlet is 500 and 500 degrees Celsius. Mass flow rate is about 50. Okay, hit apply. Okay, go for here and hit run. It will self just at 0 time. It's just 1 point, so you can extract your data at a specific case. Okay, specific case. Suppose I'm going to change all of this. I need transient. Okay, for transient you have to deal with right clicking or your mask parameters. Okay, for here, let's go for mask, edit mask parameters. Okay, for edit mask parameters you have to go to parameters and dialogues. Let's go. Suppose I'm going for solar radiation. It is a slider. I need to make it edit block. Okay, it's edit, and you can write a single point. Ambient temperature, keep it. Flow temperature, keep it. Outlet flow temperature, I will change it to edit. Suppose edit, yes. Okay. Mass flow rate, keep it. Okay, just an example. Okay, hit apply and hit OK. And if we are going to control, you will find this, it's editable. So you can enter here one value or a matrix. I'm going for a matrix. Suppose I need to inspect 200, 300, 400, 500, 600, 700, 8, and we have to draw back again. 750 as a sine curve. 750, 640, 555, 434, and 320. Okay, you have to realize that the number of I have to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a 12 value. So outlet temperature, suppose it's 500. Okay, let's go here, open your console and hit run at 0. At 0 time, you will find this. It's a matrix here. You will bring yourself in a matrix, as you can see here. It's 11 values based on your selection, as you can see here. It's depending on your interval. So you can go outside to your workspace. I'm sorry, you have to click this and hit run again. Hit run again. Okay, going here. Okay, this it's a 12 values. Okay, 12 values based on the changing of the 12 values of solar radiation. You can plot. This is the solar field area depending on solar radiation changing. So you can draw solar radiation with or solar field area with respect to solar radiation and plot. Okay, this solar radiation values up and down against solar field area. Okay, and this is our solar radiation based on time. Okay, I'm sorry, solar radiation based on time. This is hours. This is hours. Okay, 3 hours. Okay, so you can do. Suppose I'm going to change another parameter. If you are going to change another parameter, you have to put in consideration the matrix dimension. This is a matrix. We have 12 values, so we have to add here to the same number of values. Suppose I'm going for 12 values, maybe 300, 350. You can use Matlab experience for this one, suppose I'm going for 500 and 550. That's enough. So 1, 2, 3. This is 6 values. Okay, let's go here for 6 values. Okay, the same dimension changing. Let's go and hit run. So we have two parameters affecting on the solar radiation area. Okay, as I expected. So we can draw here. I'm sorry, solar radiation. Okay, this solar radiation, and this is the changing in solar field area based on your selection. So you can any output data depending on these two parameters you will find here as a matrix, as you can see here, matrix. So because it's depending on temperature, everything you will find here as a matrix, as you can see here. So you can draw many you can draw multiple as you can see here, for example, solar radiation versus so you can go here and you can go for, and you can choose some figures, and you can draw add data. X is solar radiation, the effect or outlet temperature, and okay, this temperature variation versus area you can add here. Temperature variation versus total exergy inlet, outlet temperature versus for example total system irreversibility. Okay, and you can add here, for example solar radiation versus I think some kind of number of collectors. Okay, solar radiation effect. So you can build your it's outlet data. So if you go here, double clicking, you can use this and go for application, and you can make your curve fittings, the same outlets, same parameters. So suppose it's solar radiation and outlet is collector temperature or area. So you have here, you can make a correlation. So I'm going for exponential second degree. So this is your correlation, the solar field area versus solar radiation effect. Of course you can add another effect. Suppose it's outlet solar collector temperature, and the third one is yes, area. So I have it's three-dimensional now. Solar radiation plus outlet field temperature, the effect on outlet I'm sorry, the total field area. It's a three-dimensional, so we can make this second degree. You have to watch root mean square error. You have to seek minimum root mean square error. Okay, so you can, this is a your correlation, polynomial correlation, two parameters in order to get the third one. The two parameters is solar radiation per meter square. The second one is field outlet temperature, and your result would be your total field area. I'm not going to save this. Okay, finally I would like to thank you very much for this tutorial about how to extract your data from your model. You have many types of extraction. The simplest, I do prefer this one, is Data Inspector. It's quite interesting, especially while you are dealing with the time limits or simulation time. There's another type of data extraction. It's about a signal generator block. You can go for signal generator block as a source. I'm sorry, this source. Okay, run the number. Okay. Okay, signal builder. You can do this by creating your signal by yourself. You can add many signals. Suppose I'm going for, but I need to explain this in another video. So we can control all data at the same time. Suppose I need to enter 4 inputs, so you can make 4 signals here, in order to extract the real effect of each signal on the output, your output. It's quite interesting, and you can do this. You can edit and make edit here and make edit here, no slider, and you can edit even in your mass flow rate. But you have to be aware about your matrix dimensions, the same number of matrix, column or vector. You have to do this. Finally, I would like to thank you very much for your interesting. Don't forget to like, share, subscribe. Professor Mohammed Sharaf with you, Let's Library.com. Thank you very much.